what you think about how we might solve that. Oh, Trig's already got it done. How did you solve that, Trig? He used the quadratic formula. Could we use the quadratic formula on this problem?
Yeah.
Absolutely, 100%. What else there's nothing wrong with that, that's fine. What else could we do with this problem? Well, we could try to factor it. I don't think this one's gonna factor, do you? Think about that? I don't think it's gonna factor, but is factoring an option for you? Yes, you can always consider it. What else, class? We can complete the square. Now, there are no directions here. So Trig said, I'm gonna use my time effectively, I'm gonna just jump in. I'm using the quadratic formula, that is fine. For our purpose, for practice, I am going to do this one by completing the square, and I'm going to do this one with the quadratic formula, just so we practice both methods. But actually, there's no directions here, so it doesn't make any difference. All right, but I'm going to practice completing the square. So, and then we'll compare our answers to it. So, if I'm going to complete the square, what is the first step I need to do?
Subtract the 2.
Subtract the 2. I'm getting ready for a test in which there might be a question that says, solve by completing the square. Okay? I want to make sure I know how to do that. So, what's next? Take half of 4 and square it. So I'm actually going to add 4 to both sides. Is that okay with everybody? Happy with that 4? Half of 4 squared. Now, what is this? This will always be a perfect square here. X plus 2. And we said it, it's right on target. X plus 2. X plus, that's the sign you use always. And then 2, because 2 squared is 4, equals 2. And then what? Square root. So x plus 2 equals plus or minus 2. Now square root 2. And then subtract 2. True, is that what you got when you did it with the quadratic formula? Absolutely. You're going to get the same answer no matter how you do the problem. That's the method of completing the square. Okay, now this one I'm going to use the quadratic formula actually. This one suspiciously looks like it might factor. But I'm going to go ahead and do the quadratic formula. So x equals negative b with the opposite b plus or minus the square root of b squared. And I've noticed in some of your work that when you square this, and I don't know if you're trying to do it on a calculator or what, it's always going to be positive. Some of you are including a negative. When you square negative 9, it's going to be positive. 81 minus 4 times A times C all over 2. Everybody okay? Remember, you need to know the quadratic formula. You need to write it down over the side, that's fine, totally fine. But you need to know it. Alright, here we go. 81 minus 56. Is that 25? Which is absolutely great news, because the square root of 25 is 5. I'm still going to get 2 answers. My 2 answers are 9 plus 5 divided by 2, which is what? 9 plus 5 is 14 divided by 2 is yeah, that's a 4. Thank you. That's what she said. So is that supposed to be a 1? That's not right. This is supposed to be a 4. There we go, that's better. Is that what you were asking me about?
Yeah.
Yeah, 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 by denominators 4, not 2. So 7 halves and 1. Yep. What did you do to get 21? 80, I multiplied these together and got 56. And 81 minus 56. Okay? All right. Now we had a couple of review problems from yesterday. This was all review too, actually. And here are a couple more reviews. We did one of these yesterday. Does anybody remember what happens here? Foil. So carefully. First, outside, inside, last. And then we simplify. These two obviously are going to add together and make I'm on it. Negative 13i. Now, what is this guy here on the end? What is he? He's actually going to be positive 14 because I squared is negative 1, but he's already negative, so he's going to become positive 14 when I can add into the 12 and get 26. Is that all right? And then we did one like B yesterday too. Who remembers what we do with B? Anyone remember? What do we do? Multiply by the conjugate, and that sounds really fancy. What do we mean by the conjugate? 3 plus 2i. Remember, when you do the conjugate, you only change the middle sign, and you do it for the denominator. It's the conjugate of the denominator. And now we just start with it. You do it, I'll do it, we'll compare answers. First, outside, inside, last. You have to put it on the top and the bottom. Don't just copy down what I'm doing, because first of all, it could be wrong. And second of all, you need to practice as well. Before we start simplifying, I need somebody to check my work. Did I FOIL correctly?
Yeah.
Yeah? So now I'm going to start simplifying. So that's going to give me a 31i. And then 14i squared is negative 14. So I have a 1 up there. These cancel, which will absolutely always happen, right? What's this? What's negative before I square? plus 4, so the 14 down there. And once in a great while, you'll get something that you can simplify. But remember, if we're going to simplify, you have to be able to simplify in all spots. So if you had a situation like this, where you could take out a 2, a 2, and a 2, you can do that. But if you don't have that situation, then you zero it. You okay with that? Alrighty, that's it for P6. That was all the new stuff actually. And now we're gonna start our last little section, P7, and it is all about inequalities. So we're solving different kinds of inequalities. Okay. Now, this is one of those moments in time when the beauty of math comes forth, because you have already learned how to do that problem. And hopefully you're comfortable, maybe you're not, maybe you don't remember from last year. But I'm going to give you a new way of doing the problem, and I will never tell you how you have to do it. I just want you to have two options. You can do it however you want, always, it never matters, do however you want, but we got to have the same answer. We're going to end up with the same answer, all right? Does anybody remember how you did that problem last year? Oh, you don't remember? Well, then let's just look at the calculus way of doing it, which is actually easier. This is the easiest way to do it. I'm going to draw number 1. And right in the middle of the number line, I'm going to put the opposite of that inside number. So that would be 2. So right in the middle of the number line, I'm going to do 2. Now, I don't want you to be confused by this. Think about when you factor a problem like this, factor. When you go to solve, what does x equal? X doesn't equal -2, x equals positive 2. This is the same idea. Think of that as like a parenthesis. So x equals 2. Or that's not the answer, that's where I'm starting, 2. In the middle of my number line. Now, I want you to count forward that many. So if we started our starting number, which comes from the absolute value, and count forward 3, where will I be? 5. But now I gotta count backwards 3, and where would I be if I counted backwards 3? -1. Now, I'm gonna put open dots, because that makes sense to you that they would be open. And now I need the shape. You will always be shading either between your dots or outside the dots. Take a look at the problem. Notice it's a greater than. Where do you think you might be shading? Do you think you're shading inside, or do you think you're shading outside? Outside. You want to be greater than 3. So you are out here. So you have a 2-part answer to your problem. Your answer is everything from negative infinity to -1. Does that make sense? Or, that means or, everything from 5 to 3. Notice that your starting number is not part of your answer. Okay? You just use that as your starting number, and then you do the counting to get your actual dots. So let's look at the next one. What do you think I'm going to do here? Here's my number line. What? Right in the middle. What was in the middle? So where will you be if you count forward 6? At 1? And then backward 6. Start at -5 and go back 6 for the -1. So this middle number is the middle of the number line. And this tells you how far to count. But this time, those dots will be closed. And since that's a less than, remember, here's your 2 dots. You're going to shade between them, you're going to shade outside of them. Since it's a less than this time, we will shade inside. So our answer is -11 to 1. Not a 2-part answer, it's a 1-part answer. There's one area that is shaded. There it is. Now let's look at C. What is different about the way C looks? There's something different about it. That right there. Any thought on what we might do? Divide. Now just make sure you divide everything. Everything. You might want to, it doesn't matter, you always have to do calculators, so it doesn't matter. And you might want to think about 7 halves as 3 1/2. Right? So here's my number line. What's going to go right in the middle of the number line? The middle number, so that's going to be 4. And then we're going to count back and forth how much? 3 1/2. So if you start at 4 and count 3 1/2, you would be at 7 1/2. And if you back up 3 1/2, you would be at 1/2. Now if you're struggling with that, kids, you always have access to a calculator. You're going to take 4 plus 3.5. And 4 minus 3. Then you figure out, should those dots be shaded, open or closed? Closed. And am I going to shade in between the dots or outside the dots? Outside the dots. Greater than. Greater than. Then I answer in an interval. So I'm going to start over here. -infinity to 0.5, and I'll use a bracket, or 7.5 infinity. When you shade out, you're shading 2 parts, so you have 2 parts to your answer. When you shade inside, you only have 1 part, so you have 1 answer. No infinities here in between. Alright, is this easy? I think it's easy. Alright, let's try it again. Now, you aren't always allowed to do this. For example, is 7 minus 9 the same as 9 minus 7? No. So you're not allowed to just randomly switch subtractions. However, is this the same as this?
Yeah.
Okay, so as long as I'm inside absolute value, I can switch things around. This looks backwards to me. It's kind of a personal issue I have. That looks backwards to me. So I'm going to turn it around. And that is perfectly okay. I don't change anything. I just turn those 2 numbers around. Everything else stays the same. And now it looks like it's in the right order. there's a 4. So what am I gonna do? Divide everything by 4. And I'm going to have fractions, which is fine. If you would rather use decimals, that is fine. In this case, I'm going to leave them fractions because I have a common denominator, so it'll be easy to work with. So here's my number line. What's going to go right in the middle? 3/4. And now I'm going to count this way and this way, 9/4. So what is 3/4 plus 9/4? 12/4, which is 3. Now again, I don't want anybody getting like stressing about the arithmetic. You have a calculator. 0.75 plus 2.25. If you want to do it decimal, type it in on the calculator. It will say 3. What is 3/4 minus 9/4? I'm backing up 9/4. That will be negative 6/4, which is negative 3/2. If you do it on the calculator, it's going to say negative 1.5, which is totally fine. So one more time. 3/4 plus 9/4, 3/4 minus 9/4. Now, dots open or closed? Shade it inside or outside? So your answer is simply negative 3/2, comma, 3. Okay. All right. Take a look at the next problem. Whoa, 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 it looks different. I heard somebody say, how we're gonna start it. Whoever said that, say it louder. What are we gonna do? Factor it. We're gonna factor it. We're gonna factor it. In this section, every problem you have is gonna be factorable. Now, does that mean you have to factor it? No, you can do the quadratic formula or something, but factoring is going to be the quickest way to do all of these. So, who remembers how to factor? X minus 5 plus 1, I love it. Now I'm going to draw a number line again. I got 2 X's, so I'm going to have 2 dots on my number line. Anybody want to take a wild guess where those 2 dots are going to be? At negative 1 and 5. Yep. There they are. I want you to think about, when we look back at the problems we just did. We did 2 less than problems, and we did 2 greater than problems. What was different? Look at the answers. When it was a greater than problem, what did our answer look like when it was a greater than problem? Shaded out. And when it was a less than problem, we were shaded in. I wonder where this is going to be shaded. Out. Yep. When you have 2 dots on your number line, less than's going to be in between them, greater than's going to be outside of them every time. So what am I going to put in the answer line? Negative infinity to negative 1. Oops, are those open or closed dots? Or
Isn't it wrong if you put the U or if you put the U between
Is it, what did you say?
Like, if you don't put the U between them, isn't it considered wrong?
Yeah, you have to have something between them, and the word or would be the correct word. But since we're using interval notation, we're gonna use the symbol. So, yeah. And then you're always gonna have that, it's never gonna be something different, it's always gonna be a U. If you have multiple answers, it's always gonna be a U, okay? All right, let's look at the next one. I promised, and I'll keep my promise, these are always gonna factor. If they're an inequality, they're gonna factor. So can anybody see how this one factors? Plus 10, minus 1, I heard, I think that's right. By the way, you should never miss a factoring problem, because you can check, right? She thinks this is the answer. If she foils this back together, she doesn't get that, right? If she doesn't, then she's factoring wrong. All right, here's my number line. Where are my dots? Negative 10 and 1. You with me? Open or closed? Closed. Look at the sign. Shaded inside or out? Inside. Answer. Negative 10, 1. There we go. That took us about 20 seconds. You try C. You and your partner try C. Here's what I got. That was good. One thing I didn't mention, I think you don't need to be told this, but just in case, when you put your dots on the number line, you know you're gonna have a dot at 5 and a dot at -2. They have to go in order. I mean, this is a number line. So you've got to make sure that you have -2 here and 5 here. Is that okay? All right, there's one more, just like that, D, right here. And make sure that you're writing your answer correctly.
I do too.
So, that doesn't make it a big problem. So, factor, these factors. Okay, so think about when you solve one. You say x plus 2 equals 2, doesn't x equal negative 2? So it's the opposite of the all right, I need somebody to tell me what you wrote as the answer. This picture is beautiful, but it is not the answer. This is like my work. The answer is what? Negative infinity to negative 3. This is a parentheses always. This is a bracket because that's a close dot. My union symbol, my U. Bracket on 2. Parentheses on 3. Alright, how many of you got that right? What? Negative 2. Get that right? Good? Okay. We don't have time to do it, but I'd like you to look at E and tell me what's different about E. E is a cube, so we're going to tackle this tomorrow. And what a cube means is that you will have 3 dots on your number line. And then you got to start thinking. Oh shoot, we don't. So you'll have to wait till Friday to get that great excitement. Sorry about that. P6 is due Friday.